My name is Angela Ludvigsen. During the summer of 2015, my research advisor is Professor Jacques Robert. Professor Robert is engaged in research on ultra-cold hydrogen beams. At a pressure of about 10 to the negative 6 torr, gaseous H2 molecules undergo a radiofrequency discharge resulting in the creation of electrons and H atoms. The H atoms are directed into a chamber and cooled to 10 Kelvin using liquid helium cryogenic cooling. This allows the atoms to gain a density factor of about 5 with respect to ambient temperature and reduce their velocity to 400 meters per second. Once available, a 121.6 nanometer quasi-continuous wave laser will be used to slow the 400 meter per second H atoms to 10 meters per second. This will result in a slower beam of H atoms and a well-characterized velocity distribution. I came into the iREU thinking that I'd work on an aspect of Professor Robert's project and have deliverables to show for my time. To my surprise, my first requirement was to learn and not to do. I spent many hours reading research papers and learning about my mentor's research in ultra-cold hydrogen beams. I discovered that the purpose of the iREU was to help me to understand what it was like to be a scientific researcher, devoted to learning and to research. My advisor included me in a meeting he had with other researchers. It was quite evident that professional researchers were willing to share their expertise to help other researchers solve problems. When my advisor judged me significantly ready, he gave me a challenge to build a helical copper coil and antenna with these properties. It must use 2 mm copper wire, resonate at a radio frequency of 27 MHz, and be contained in a shield of constant size. I referred to some research papers, checked our lab for materials readily available, and worked out the math for the coil. My advisor approved the design and gave me permission to build it. Once it was built, I tested the helical coil. I found that the coil achieved the highest power with a triple loop antenna. This made sense, since with a higher power, a higher discharge is produced. Under my advisor's guidance, I integrated the helical coil and antenna into the experimental system. The helical coil and antenna were wrapped around 2 concentric glass tubes, the inner tube filled with gaseous H2 molecules. When switched on and working properly, the helical coil and antenna would create a discharge of H2 molecules, producing H atoms and electrons. By the end, the helical coil and antenna were able to achieve a discharge of H2. Spectra were collected to verify that the discharge was indeed hydrogen. After researching with Professor Robert this summer, I have learned that it is important to have a goal in mind and know that there are an infinite number of paths to reaching that goal.